ore deposits associated with connate fluids. Here we are going to discuss about SSC copper deposits. Base metal deposits, which are associated with circulation of basinal brines, that is connate fluids, are restricted to sedimentary sequence. These are of two types: stratiform sediment hosted copper deposit, also known as SSC. They are also called as red bed copper deposits, and lead zinc ore associated with carbonate sediments, some of which are sandstone hosted, and these are known as MVT, that is Mississippi Valley type deposit. The major difference between these two types of deposits are type of sediments through which the fluids travel, contrasting properties of copper, lead, and zinc in hydrothermal solution, basinal brine moving through oxidized aquifer, that is red bed. Red color of the bed is because of oxidation state. They scavenge all the three base metals. The brine moving through these beds scavenge all the three base metals. What are the three base metals? Copper, lead, zinc, from fertile detrital in the basin. These fluids will be saturated in copper and undersaturated in lead and zinc. The fluid will tend to deposit copper sulfide minerals because it gets saturated in copper very much earlier, while higher solubility minerals, that is lead and zinc, will remain in solution and these can move further ahead. SSC deposits tend to have more of copper and less of lead and zinc. Some fluid, on being channeled through relatively reduced carbonate aquifer, evolve to become zinc and lead saturated in the presence of dissolved sulfur species. The typical ore deposition in MVT deposit will be more of sphalerite, less of galena, and much less of chalcopyrite. Here we have diagrammatic representation of conditions of formation of SSC and carbonate and sandstone hosted MVT deposits. Basinal brine, which is the source, basinal brine, which is the source of deposition, which that its temperature is around 100 to 150 degrees centigrade, pH is 4 to 6, and oxidation state is, fugacity of oxygen is such that hematite and magnetite are both stable. If this basinal brine source moves through carbonate aquifer system in reducing condition, it precipitates zinc more than lead and much more than copper. I mean, copper is much less than zinc and lead, in which zinc is major. When this basinal brine source moves through quartz sandstone aquifer system, it precipitates more of lead followed by zinc and much less of copper. And when this fluid moves through evaporite plus red bed aquifer system, it precipitates more of copper than lead and zinc together. Stratiform sediment hosted copper, also known as SSC deposits. In terms of copper production, SSC deposits are worldwide the second largest producer after porphyry copper deposits. The most important global source of cobalt, these are the most important global source of cobalt and many other metals like lead, zinc, silver, uranium, gold, Pg, and uranium. Stratiform sediment hosted copper deposits can be of two largest, the two largest types of these deposits are Neoproterozoic Central African Copper Belt, Thermo-Triassic Schiefer or copper shale of Central Europe. The tectonic setting in which these deposits form can be intracontinental, rift-related sedimentary sequence. The copper deposits are present within a few kilometers of the margins of intracontinental basins, in which rift phase fill composed of basalt lava flows and a mixture of sedimentary rocks, which are partly terrestrial sandstones. The host rocks of the ore bodies lie at or above the top of this rift face composed of terrestrial sandstones, organic rich shales, and massive dolostones. The whole sequence was deposited at low latitude in desert climate. That is the climate in which copper can be abstracted more easily, and wherever the reducing condition is uh, encountered, deposition takes place. The originally deposited or rapidly oxidized deposits during burial and diagenesis sedimentary sequence is aeolian to evaporitic assemblage. During shallow marine transgression, more reduced shales, carbonates, and evaporites overlaid these sequences. These are promoted by high heat flow conditions because we know that for copper to be dissolved in fluid, temperature needs to be high, accompanied with rapid rifting and subsidence. Basin derived fluid circulated through the very porous and permeable clastics and active growth faults. The stratigraphic setting of the ore bodies within the host basin is characteristically at or near a flooding surface above red bed continental sedimentary rocks. Saline connate fluids circulating were relatively oxidized and pH neutral. Copper was leached from detrital minerals like magnetite, biotite, hornblende, and pyroxene. All of these minerals are copper bearing. So these minerals are leached out of copper, and uh, copper is derived from fertile basement assemblage. Solubility of copper as a chloride complex is estimated to be 35 to 100 ppm. Metal deposition occurred at a redox interface where the oxidized metal charged connate fluids intersected overlying or laterally equivalent reduced sediments or fluids. Typical ore deposit zonation at district scale is like this: barren hematite, then native copper, followed by chalcocite, mornite, chalcopyrite, lead, zinc, cobalt sulfides, and then pyrite. Hematite represents oxidizing condition, then native copper, the highest percentage of copper precipitates first, followed by other minerals. Low temperature, that is less than 150 degrees centigrade, neutral range of pH, that is 5 to 9, ore fluids, uh, um, pH around 5 to 9. Ore fluids interacted with the dominantly clastic oxidized sedimentary sequence. There are two subtypes of deposits hosted in continental red beds. These are less important one. These are originally oxidized with ores precipitated around locally developed zones of reduction, and such locally developed zones of reduction area is small, usually small, so the deposit size is also small and the deposit is less important. Metal deposition in more reduced shallow marine sequences were partially oxidized after deposition. These are also known as red bed deposits, and oxidized red bed sediments occur stratigraphically beneath the ore zone. So the ore zone forms above the red bed, which provides the metal to the circulating brine. Copper is relatively insoluble in normal meteoritic water. It is unlikely to be leached from more reduced sediments in which copper sulfides are stable. Breakdown of detrital minerals in an extensive red bed sedimentary environment underlying the ore zone is a source of copper metals. Here, copper chloride in complexes result in high copper solubilities and so is ideal for formation of copper more than lead and zinc of SSC deposits. Precipitation of the ore may have been induced by fluid mixing so that the solubility of the metal reduces, or interaction of oxidized fluid with reduced country rocks. On encountering reduced rock, the sediments of the metal precipitates. A fluid with high initial copper content becomes progressively more dilute as copper sulfides precipitate. Paragenetic sequence, that is formation of the minerals, sequence of minerals formation and zonation pattern produced, reflects a decreasing copper content in the sulfide ores such as chalcocite followed by bornite, chalcopyrite and pyrite. So chalcocite has the most highest copper content, pyrite doesn't have any copper. Ore minerals are disseminated in the host shale, precipitated in primary pore space between clasts, also present as fractured and fault fill, which might have formed as a result of remobilization of early disseminated ore. Thank you so much.